we're going to go through problems 2, 3, and 4. So all looking back to 13.2 when we started talking about angles. Problem 2, find the measure of an angle between 0 and 360 coterminal with the given angle. The word coterminal means that it's an angle that has the same terminal side, so it'd be in the same position on the coordinate plane. To find coterminal angles, all we need to do is either add or subtract 360 degrees, because every time you add 360 degrees, that would make a full circle and get you right back to where you started, or subtracting 360 degrees. If I'm at negative 32, if I add 360 degrees, that's going to get me in between 0 and 360. So I have negative 32, I add 360. That's going to bring me up to 328, which is an angle between 0 and 360. So negative 32 and 328 degrees are going to have the same terminal side, which means they'd have the same sine and cosine as well. Problem B, 375. I'm above 360, so I want to get back into that range of 0 to 360. So I am going to subtract 360, and that's going to bring me to an angle of 15 degrees. So that also gets me between 0 and 360. And anytime to find a coterminal angle, you're going to either add or subtract 360. Problem 2, we're going to write each measure into radians. Express our answer in terms of pi and also as a decimal rounded to the nearest hundredth. I am not going to show the decimal to the nearest hundredth. You can do that in your calculator. We're just going to talk about the process of dimension analysis to turn these degrees into radians. So we'll start with our degree measure, negative 225. What I like to do is, with this dimension analysis, we are dealing with multiplying fractions, but I just make a little grid. So I put this over 1. So there's my first fraction. And then the conversion factor we use is that pi radians is equivalent to 180 degrees. And whenever you're doing dimension analysis, this will be a process you use if you're planning on taking chemistry next year. If you work with any type of science field, you'll do a lot of converting units. Is you want to get your units diagonal from each other. So we've got those degrees diagonal from each other. Now we're ready to start our dimension analysis. So what happens is, similar to how similar factors will factor out, your degree units will factor out. Then 225 and 180 are actually both divisible by 45. So 225 divided by 45 is going to be 5. 180 divided by 45 is going to be 4. So negative 225 is going to convert to negative 5 pi over 4. And all I did at the end there is I just multiply across. 5 times pi is 5 pi, or negative 5 times pi is 5 pi, and 1 times 4 is 4. Now you can convert that to a decimal. Just go into your calculator, take negative 5 pi, divide it by 4, and you'll get that answer as a decimal. Part 2, we have 120 degrees over 1, and then we're going to multiply it by a conversion factor. So again, we're going to get our degrees diagonal from each other. There it is. Now we can 120 divisible by 60 makes 2. 180 is divisible by 60 makes 3. 2 times pi is 2 pi. 1 times 3 is going to be 3. So we get 2 pi over 3 radians. And again, you can change that to a decimal on your own. But you will see as you get into physics, chemistry, or you work in the science field, this dimension analysis, you can continue and make more conversions with any type of rates, speeds, things like that. It's just a good skill to start practicing. And we're just using this to convert to one different unit. That's it. Now we're going to go from radians back to degrees. So here we're going to have 5 pi over 6. So I'm going to write that as a fraction, as it is. 5 pi over 6 Now I'm considering the numerator to be where my units are, so I'm going to multiply this by 180 degrees over my pi radians. And we'll get some simplifying. Pi's will cancel. 180 is divisible by 6, makes 30. And 6 is divisible by 6, makes 1. So we will multiply. 5 times 30 is 150 degrees. And 1 times 1 is just 1, so that's going to be just 150 degrees. So far, all three that we've had have been on the unit circle. So you can go and find 5 pi over 4, that would be 225 degrees. 2 pi over 3 would be 120, and then 150 would be the 5 pi over 6. The last one is not on the unit circle, so this one we have negative 2.5 pi. But we can still figure how many degrees that is. We're going to put 180 over pi. So now we've got our pi's canceling, and that's it. And up here I can take negative 2 times 180, negative 2.5 times 180. Well, negative 2 times 180 is 360, and then another half of 180 would be another 90. That's going to be negative 450 degrees. Think about your unit circle. Whoop. How many radians are in a full circle? 2 pi. Well, now if we're going 2.5 pi, we're going that extra 90 degrees. And that's going to bring me to negative 450 degrees. So there would be my degree measure for 2.5 pi radians. And it does make sense because 2 pi radians would be 360 degrees. So that's just going to be another half pi radians. So there would be problems 2, 3, and 4, which all are relating back to section 13.2 and section 13.3.